Hello and welcome to this special episode of the CORDIScovery podcast. In today's episode, we're going to be looking at two key challenges that are deeply connected to our future: food security and the health of our oceans. Researchers are developing innovative solutions to make food systems more resilient and to safeguard marine ecosystems. I'm joined by representatives of two projects that have received funding from the EU's Horizon Europe programme, and these projects illustrate how science and innovation can help secure a healthier, more sustainable future both for people and for the planet. So, Wibi, Jérôme, hello.
Hello,
Hi.
nice to meet you.
Thanks for joining us. Wibi is a geovisualization data scientist based at the Open GeoHub Foundation in the Netherlands, and she's part of the consortium of the AI for Soil Health project.
Yeah, exactly.
Jérôme is an Earth observation expert and the product manager of the European Digital Twin of the Ocean, the EDITO project.
Yeah, right.
So, Wibi, if I could start with you, your project aims to use artificial intelligence to improve soil health, and you're working, if I understand correctly, on the development of a soil digital twin. How does that relate to the EU's soil mission, which aims to transition to more healthy soils by 2030?
That's correct. But if we're talking about soil digital twins, we try to adapt the concept of digital twins, but right now we're not exactly in the digital twins for now.
You're sort of working towards
Yeah, working towards it.
Right.
Right now it's more of like decision support tools, if I may say. So we created the data sets in the European scale, 30 meters, which then can be used for decision supports information for like general people, farmers, researchers. Because we created this data also is fully open source. Everybody can access it. Everybody can use it. No licensing, just CC by 4. Everybody can use it basically. And
So the data was already there, or you had
data
to...
is already there. Everything
Okay.
is already published. Yeah.
Right.
And as we know, like soil is like pretty important stuff in this world. So especially for our farmers and stuff like that, by them knowing like what kind of soil properties they have. For example, I should have explained that from the first time. So we map several soil properties. The data set is from the soil scientists. So we have a legacy data from all the different countries, and we collected them, we filtered them, and we cleaned them. We also measured new sample in a pilot sites with the help of the soil missions community and the living lab, basically. And we use those points to create the map with the machine learning algorithm, basically.
Right.
I combined it with the satellite data.
So there's kind of like, if I understand correctly, a citizen science dimension to your project in that you're getting people to help you collecting the data that you can then feed into your...
That was the next deliverables, basically. But right now it's collected by a proper soil scientist. So it's like a proper data of measurement of soil properties, like carbon, acidity, and stuff like that.
Okay.
And then we map them. We use one of method of the AI, which is machine learning, to find a pattern, and they will predict like the value around the points, and we'll get like a map of a whole Europe.
Right.
Technically, yeah.
And what is the data showing you? I mean, how concerned should we be about the state of Europe's soils?
As for the state of Europe's soils, I think it really depends on the places, but in general, we can see like a decline. If you visit our website, ecodatacube.eu, and checks one of the soil properties, because our data is from 2022, so it's temporal. Everybody can see the changes. And you can notice like most of part of the Europe have like a decline soil properties, which is of course not good. Yeah, like decreasing soil carbons. But mostly like this decreasing soil carbon happens in the city because of the impervious surface around the coastal area and stuff like that. But of course the fields also affected because with the way of farmers handling their fields with the chemical they use and everything like something like that, this also affect the carbon content, for example, in their area. So this is also useful for them to check by the temporal factors. Like we can get like a statistic, basically like a line over years. And they can check, I have like a pretty good peak increase in certain years. What did I do at the time? Why do I have like a big decline in the next year? So that's why I say they're more like a decision support tools, because they can check by themselves and they can see and go back to how they handle their farms.
Right.
And they can like review their method further.
Yeah. And what actual practical tools are you putting in the hands of farmers? I believe you're working on a smartphone app. Is that already available?
Exactly. The smartphone apps will be available next month, the first versions.
Okay.
So the way we use AI is two things. One is the machine learning that I would just tell you about. And the other one is the large language models. This one is pretty common. It's like a chatbot and stuff like that. We make a prompt and ask, and they give the answers back. Basically, if we are not a really soil scientist, we wouldn't be able to tell what does the soil properties means. If it's certain levels, what does it mean? We wouldn't know, basically. So because of that, we created the mobile phone app too. So this will include the chatbot. This chatbot will try to interpret the soil properties and tell the user what does it mean for them. For example, a farmers can tell, can you see my location right now through the geolocations and tell me what is the pH of my farm and what does it mean for me? Stuff like that. So the LLM, we tune it or we train it in simple terms to make simple lines or simple sentences that is easily understood by the general public. Because we already have like several other platforms that, of course, the researcher can use easily, and it's more complex, but that's not ideal for the other users. Yeah.
Okay.
Basically that.
Thanks very much. And I think we can come back to some of those issues perhaps in a more general discussion in just a moment. But first of all, let me turn to Jérôme and bring you in. So one of the main outputs of your project or what you're working on is the digital twin of the ocean. Can you just explain to us briefly what exactly that is?
Yeah, okay. First, perhaps a digital twin of the ocean. It's like a replica of the ocean, a digital replica of the ocean. So you can see it like, a globe, and when you can see all the physics of the ocean, which means, for instance, the ocean, it's like, you see the water temperature, the salinity, all the winds, the currents, everything related to ocean. And it's interactive, meaning that you can play with this globe. So, it's like in the Google Earth, you see the Earth and you can play with it. But here we are talking about science and the digital globe of the ocean. It's really about replicate the physics of the ocean, the physics and the biology of the ocean. Meaning, for instance, that you can see past condition of the ocean, but also future condition and forecast. And here at Mercator, I work for Mercator Ocean International. We are in charge of a Copernicus Marine Service. And basically, Copernicus Marine Service is about giving forecast about the condition of the ocean. So you have on a daily basis, you have a 10 days forecast of all of the ocean. How will change the temperature, the salinity, the current, and so on. And the digital twin of the ocean is about taking this data and also other data from in situ data, satellite data, and so on, and to put in place computing resources on top of that in AI, so we can give and develop application, what we call what if application, that allows decision maker from state or public to ask question about what if I'm doing this, what is the result?
What difference does it make for the other variables and different outcomes? And I think, Wibby mentioned that you have data covering a 2 or 3 year period, 2020 to 2022. Yep. I think you have much longer time series data for the digital twin of the ocean, right, Jérôme?
Yeah, exactly. For the physics of the ocean, we have models from the 90s. Starting 90s, so 30 years of forecast. It's the forecast we call incast now. So 30 years of reanalysis of this forecast. So basically, we have 30 years of sea temperature, current, salinity, and so on. So it's very important because this way we can see really trends and we can see change, for instance, due to climate change, all these parameters. And this is very important, in particular for AI, for instance, because you know that AI, you need to train it with data. Yeah. And the more the data you have, the better it is. The older they are, the more the data you have, and the more accurate it is if you want to predict change.
Yeah.
Sure.
And how Oh, sorry. Yeah, would be pleased to come in. Yeah.
No, I'm agreeing with it.
Okay.
The data is very important. For example, for our case, soil properties like varies, right? They have a chemical, they have physicals, they have the biological as well. For us, the biological itself, we didn't map it because the model is not ended up so good because of the lack of the data and the noise inside of the data. So in this kind of process where you use AI on the type of machine learning, it's very important to have like a good data, also clean data and enough data for like at least especially for him, it's like a whole globe.
Yeah.
That is like a proper data with the distribution as well.
Yeah.
So it's like a good point. Yeah.
And can I ask Jérôme, I mean, what is different between this digital twin approach and, computer modeling, which has been around for quite some time? Is it the AI dimension or what's new?
Yeah, in fact, of course, digital twin is using a computing model of course, but you can see it as the computing model are a bit like static. You have just forecast data that is a bit static. It's very science related, and the digital twin is about dynamic stuff. It's interactive. You use this model, but you can play with it, and it's easier for non-expert people to understand that. So it's more the way that the dynamic of the stuff, and AI, of course, on top of it, can bring some new stuff about this new way to extract information and to ease the understanding of the ocean. But really, it's really about modeling, of course, because we use a lot of modeling. AI is training with modeling and so on. So it's not at all the end of old school modeling. I would say not at all. But it's like taking a snapshot with modeling versus to have an interactive way to play with it. So that will be the main difference with digital twin of the ocean.
And how can you be sure or check that, the ocean environment is a very complex and multidimensional ecosystem. How can you be sure that the model correctly reflects the interplay between the different factors?
Yeah, as you say, the ocean is an incredibly complex medium. I mean, it's interact with everything. And of course, there is no one model, fantastic model that will magically explain everything. So we have basically a particular model for each of the parameter. And you can see the digital twin of the ocean as a kind of, you have multiple layers. Like, for instance, you have the layers where you have the ship routing, you have the physical information, you have fishing efforts, you have pollution from any kind of information. You can mix everything, and when you have a model to track every of this aspect. And with the digital twin, you are able to mix everything to try to extract information from them to do this. So of course, in this area, AI is very useful because it helps you to manage all this data, because on the human level, it's very difficult to manage when you have a lot of data like this. And AI can help you. AI can help you to find trends, for instance, subtle change that are extract from this tool.
I don't know. It sounds like for the digital twin of the ocean, you have more years of data that you can use, perhaps more diverse data. Is in your journey towards a digital twin of the soil? Do you think you need more data in order to be able to have reliable?
You mean for the other years, other interval?
Other years? I don't know. Perhaps other factors.
Yeah, we do need more data for that. So for the current soil properties, that the layers, the maps that is out, it's the one that with actual clean and enough data for us to model and map it. Of course, from the legacy point itself, the data that's collected by soil scientists in the Europe, it's also contain data sets starting from 1960s, 1970s. But the distribution of this data itself is not comparable to the one in 2000, 2022. So if we can model it, we can map it, but the quality will not be the same, basically. So that's why we didn't do that. It's the same reason with the biological properties of the soil.
Yeah.
Basically, yeah.
Okay.
Yeah. And I think for the digital twin ocean, you have a what-if scenarios, right?
Yeah.
Yeah. That's why I'm saying that we are more like a decision support tools, because I know there's a clear line between digital shadow and digital twins. And what part of it is the scenario-based situations, which is the what-if that they had. For us, we're not there yet. So which is very interesting. I love what if scenarios.
Yeah.
I really love your setup too.
Thank you.
Can I ask Jérôme, Wibi's project is working, amongst others, with farmers to provide them with tools they can use. I mean, you potentially have a lot of users for the digital twin of the ocean, everything from politicians and policymakers to the shipping industry, fishermen, the fishing industry. What kind of use are they making of the tool? Do you do anything in terms of outreach to those different communities to explain to them what's available and encourage them to use it?
Yeah, and the digital twin, the European digital twin of the ocean, the EDITO project, as we call it, is pretty new. It started 3 years ago, but it's based on, as I explained, it's based on data that are here for a long time. In particular, it's based on the Copernicus Marine Service. So the Copernicus Marine Service, that's a European service. So perhaps I can introduce the Copernicus project.
Yeah, please do.
It's a flagship project from the European Commission. So basically, the Copernicus project is a monitoring project of the Earth, and so it means that we have satellites, we have in situ data, and so a lot of data to monitor all the aspects of the Earth. And there are 6 services. So the marine service, the land service, the emergency service, weather service, climate change service, and so on. And so the marine service is about giving forecast data on the ocean. And this is, of course, used by a lot of people, from scientists to industry and to private companies that make business of it. There is something like more than 100,000 registered users, million of downloads per month. And so this is a base data that is used. So the digital twin of the ocean is built on top of that, and built on top of also another network which is called EMOTNet, which is about in situ data, is here to fill the gap between just giving the data and help people to make decisions and to have information extract from the data. So we put in place the infrastructure and the tools, so computing resource and tools to do that. And so to more directly answer your question, for the moment, for the first 3 of the project, it was basically more on a research project, meaning that we are also discussing a lot with a researcher and with scientists that develop models on top of it. And we developed some what-if scenario just to showcase how it can be used, not only for scientists, but also for decision maker and general public. So basically, we have, for instance, for fishery, we develop a what if scenario on Sargassum algae. So Sargassum is an algae that goes to the Caribbean, and when it goes to the beach, it's a bit of a problem because there is bad gases that are from this Sargassum, and it's bad for the tourism, it's bad for everything. And we have a model that detects Sargassum from satellites, and then a modeling of drifting of the Sargassum, and when it will arrive in your exclusive economic zone, and then you can go with your boat to fish it. Because it can be also a resource, because if you take it, you can use it to make bricks, for instance, to build houses. So this is an example of something that is a problem. So on the beach can be also an opportunity and resources. But to know that, you need to know as a fisherman when the Sargassum will come. Is there sufficient Sargassum so it's interesting economically to take the boat in Sargassum and so on. So this is a kind of example we have. And the idea now with the next phase of the EDITO project is to onboard this kind of, I would say, public or private user to use the platform and to make the best of it. Okay.
And Wibi, is there an equivalent example that you could mention, either that has happened or that you could see happening based on the data you're making available on soil health?
In what case? Sorry.
So the example that Jérôme
gave, the scenario bit.
Yeah, is there a kind of use case or scenario that you could mention?
Not a scenario-based situations, but if you want me to give an example of the usage of this data, I can tell you that because we are also like within the soil missions. So we also have a collaboration with the Living Lab and stuff like that. In fact, yesterday we have like a course in the Spain by the Living Lab as well. So this course, we also use this platform that we currently have published, the Ecodata Cube. And we educate the farmers basically, like how can they use this. And I think yesterday they were testing it and in one of scale of their farm, for example, 1% farms, and they checked in the temporal factors by the statistic by time from 2000 to 2022. And they do exactly what I told you in the first time, like about there's like a steep increase and steep decline in this certain years. And they go back to their farming methods and they check whether what kind of chemicals they use, what kind of stuff they use to take care of their farms. And this actually makes sense and correlate a lot with the data sets that we have, the layers that we have. And they can actually tell like which part of their farming methods did cause this. And then they can plan for in the future, so what kind of method they should have done for certain kind of plants, for example. Because our data is also based on the depth as well. So depending on what type of plant they were planting, it will they need to see which depth does it correlate to. So of course, each depth have different patterns. For example,
I see.
Yeah,
I see. Perhaps just a last question for both of you. I mean, things are obviously evolving very quickly with artificial intelligence and so on. If you could look into your crystal balls into the future, perhaps 5 years ahead, where would you see ideally your project being? You know, what further breakthroughs do you think you may be able to make, and what difference could it bring? Perhaps Jérôme, would you like to start off?
Yeah, I think ideally it would be that EDITO is the reference for oceanography. Like always I take this similarity, it's not a good one, but they say if you think video, you think YouTube, if you think picture, you think Instagram. Let's say if you think I need oceanography information and data to the EDITO platform. And with the artificial intelligence coming in, ideally what would happen, I think, is that now we start with chatbots, that when you ask a question, you say, "Oh, I would like to see the temperature in the mean temperature in the Gulf of Naples, for instance, next week." The chatbot will tell you how to get the result. The next phase will be the AI, the assistant will give you the result, meaning it is able to launch processes to use all this data, all this model, to combine them to give you the result and to really give you information. And this will be, I think, the game changer to have this amount of data, which is enormous, that is really embedded by a kind of ocean assistant, ocean intelligence, that give you answer directly because the very important thing is, I think, if there is only one thing to remember from this, is that the healthier the ocean, the healthier our future, in fact. And it's important that we make better choice. And the digital twin is not just a scientific tool, but it's like a window to open to people to see the ocean, to understand it. Yeah. And better knowledge means better choices, and better choice, it means a better planet.
So better knowledge means better choices. Do you share a similar vision for your project, Wibi?
Absolutely. We're also very excited with the mobile app, including the chatbot, it's because when we did the first feedback round with the farmers, for example, they were clearly divided into two parts. The other one that likes the visualization, the other one that doesn't really care about it at all. They just want to know what is happening. And chatbot, for sure, as he explained, it will help a lot, because nobody knows what does pH mean. Nobody knows what does like carbon content in the soil mean. What does it do with my farm? By the chatbot, they can simplify the terms and they can give like a simple explanation how it works. And maybe they also can suggest what to do based on how we train the large language models. As long as we feed it with a lot of information, that will work for sure. Then I'm very excited for this one. And we also will have the first launch next month, actually, November, for the mobile app.
November 2025, right.
I can already see that the chatbot working quite well in the back end, so I'm very excited for this one too. And for another point is like, because our company is like a non-profit organization,
Yes.
right? We strive to give like an open source data, especially for researchers. That we already kind of achieved. So we already published the European data freely. Everybody can access. Everybody can take a look at it, especially the researchers, they can use it. We, aside from the European scale, we also created the global scale. So we have another platform for the global soil data. That also already published. The paper is out, the data is out, everybody can use it. So we have we also achieved some things out of these projects, basically. Shout out to my boss, that's their ideology, which is very nice. They're researchers, they know how hard researchers find a data set, and they create a new data set that is completely open, you don't have to pay. Was it very nice mission, very nice vision from them.
Okay.
Yeah.
Before I do a short closing, is there anything that you wanted to mention that you haven't had a chance to?
No, I agree. I learned a lot about Jerome projects as well.
Yeah.
It's very interesting for me personally. So
Great.
it's very nice talk.
Just a question. Do you have an Apple application, or it will be only on Android?
It will not be on Android. It will be in the web, basically.
A web
But
okay.
the way we created with the React or the architecture, it will mimic the device, basically. We tried. We were thinking about publishing it in the app stores, but I don't think it's an option for now.
Okay.
Of course, because of the registrations, authentication, stuff like that. It's easier in the website.
Okay.
But when you use it on the phone, it will look like a mobile app phone.
Okay. Yeah. Perfect.
Yeah.
Okay.
So thanks very much, Wibi and Jérôme, for joining us.
Thank you.
Thanks also to our audience for tuning into this episode. You can follow us on Spotify and Apple Podcasts, and do check out the podcast homepage on the Cordis website. Subscribe to make sure that the hottest research in EU-funded science isn't passing you by. You can also find more information and project examples on the Cordis website, on the European Commission's Research and Innovation website, and in our online magazine, Horizon.